Moving right along, we are in section 12.6 now, radical equations. So we've been doing expressions this whole time. Now we're going to move into equations. And a radical equation is an equation where there's a variable that is under the radical sign. So let me give you an example of one. You could have something like, let's do, I like this one. The square root of 2x plus 9 equals 6. So in equation, right, we have the equal sign. And then there's an expression under the radical with an x in it. So that makes it a radical equation. You could also, there is the square root of x plus 32 equals 7. That's another type of radical equation. You have a variable under the radical sign. It's not a binomial like this, it's a monomial, but still, it is a radical equation. All right, so let's do a couple of these guys. Alrighty, so let's in fact solve and check. You're going to need to check your answers, and I will show you why in a second here. We're going to solve and check the 2x plus 9 equals 6. So when you're working on an equation, you want to try to isolate the radical as best you can. In this situation, it's already done for you. The reason we're going to do that is we need to undo a square root. So the inverse or the opposite of a square root is a square. So you can take your square root and then you can square both sides to keep it an equality. And the square and the square root undo, right? They're inverse operations. It's like adding and subtracting. If you add something and subtract something, nothing really happened. So we're just left with 2x plus 9 equals, we still have 6 squared over here, so 36. Well, now this is baby's algebra, right? You guys did this when you were 4. Solve for x. And let's see, that's going to be 27. And divide by 2. So x equals 13.5. Alrighty, and I said it's good, you need to check your solutions. Okay, so let's check and make sure it works. So we have the square root of 2 times 13.5 plus 9 equals maybe 6. So let's check it. 2 times 13.5 is 27. So the square root of 27 plus 9. The square root of 36, which is 6. So it checks. This is, in fact, our solution to the problem. Okay, let's do a different one. You know what? I've got plenty of room. I'll speed this up. All right, in the next one, we're going to use the solve and check. We'll use the square root of x plus 32 equals 7. Okay, so remember, we want to try to isolate the radicals. So, are we isolated here? Radicals hanging out with a constant. So let's move that one. So the square root of x equals, if we go minus 32, that will be negative 25. Okay. For some of you, you might be seeing some warning alarms go off. If you don't, it's okay. Okay, then we need to undo the radical, so we square both sides. So x equals the 25, negative 25 squared is 625. All right, now let's check it. So I have the square root of 625 plus 32. Does that equal 7? Square root of 625 is 25 plus 32. So that's 57. Does that equal 7? No. So this is not going to work. We have no solution to this problem. Nothing. It won't work. Here's the warning signs right here. If you take the square root of something, you'll never get a negative. So that's something to keep in mind. All right, last example. It's kind of a doozy, so hold on tight. We're going to solve and check. 5 minus the square root of 3x equals 2x. All right, is the radical isolated? No, so let's isolate this guy. Subtract 5 from both sides. So I've got negative square root 3x equals 2x minus 5. Still not isolated because there's a negative sign. So we'll divide everything by -1. So square root 3x equals negative 2x plus 5. Okay, so now it's isolated. Now we need to undo the square root. So we will square here and we will square over here. Please put parentheses around a polynomial if you have one. This is our first time having a polynomial. Make a note to yourself. Use parentheses. Parentheses. There we go. Use parentheses. Here we go. 3x equals, that means negative 2x plus 5 times negative 2x plus 5. So a little FOIL if you need to use the acronym. Otherwise, just distribute everything through. 4x squared minus 20x plus 25. So we have a quadratic term with the x squared and we have a linear term. Whenever that happens, we need to set this whole polynomial equal to 0, which means subtracting 3x from both sides. 4x squared minus 23x plus 25 equals 0. I don't know about you, but factoring this guy looks kind of tough. Factors of 100, right? 4 times 25. That add to equal negative 23. I don't think there are any. So that would be plan A if we could do it. Plan B, we have to go to plan B. Plan B is the quadratic formula. So here we go. X equals negative b. B in this case is negative 23. Plus or minus the square root of b is negative 23 quantity squared minus 4 times a is 4 times c is 25. All over 2 times a. Holy moly. Here we go. 23 plus or minus the square root of, let's see, this will be 529 minus 4 times 4 times 25. I don't know. I'll figure that out in a minute. Divided by 8. All right, doing our subtraction, we get 23 plus or minus the square root of, let's see, that'll be 129 when you do your subtraction there, divided by 8. All right, it's not going to be pretty. So x is approximately 4.29, or, this is for the add, x is approximately 1.45 for the subtraction. Then I've got to go, sorry that you couldn't see that. So 4.29 and 1.45 approximately. So now you've got to go and check. I know, I told you it was a doozy. So here we go. X is about 4.29, so let's try that one. Plugging it in, I've got 5 minus the square root of 3 times 4.29, which is supposed to equal 2 times 4.29. That's a question mark. All right, so I've got 1.41. Does that equal, this is 8.589. So 4.29, nope. Let's try 1.45. Plugging it in, 5 minus the square root of 3 times 1.45. Does that equal 2 times 1.45? And we get, this will be 2.9-ish. Hey, this is about 2.9-ish. So yes, here's our winner chicken dinner. 1.45. I know, it's a doozy. So make some notes to yourself. Quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. If you need to make that note to yourself, there it is. But always try factoring first. So much easier than quadratic. Okay, I'll see you later.